Hello. So I will be trying to solve a few mathematical problems using different programming languages. My laptop has two operating systems, so I made sure to boot Ubuntu and open terminal. I start by making a directory or a folder called assignment in my home folder. Then by the cd command, I switch to that folder, so any files I create from here are saved inside it, just for organization's sake. I start by solving a quadratic problem in Python. By typing nano, I open a separate window where I can type my code and save it and return to it to edit later if needed. Quadratic.py is just the name of the nano file. Inside the nano, I first import Python's math library to be able to use the square root function later. My second line defines a function that solves the equation ax squared plus bx plus c is equal to 0. The third line defines how to find a discriminant on which our number of solutions depend. The if, elif, else blocks are conditional statements which check the discriminant according to those conditions and decide which branch of code to execute. So here we have 3 branches. The final line gives values for A, B, and C to calculate and print the results. Then I press Ctrl-O, Enter to save the file, and Ctrl-X to exit. And by Python 3 quadratic.py, I tell it to run the code in the nano file with Python, which gives me the 2 solutions, 2 and 1. Next, I try to find the greatest common divisor of numbers using JavaScript. Again, I open a separate nano file for comfortable editing. My first line defines a function to calculate the GCD using the Euclidean algorithm. The Euclidean algorithm is a convenient way to find the GCD by saying the GCD of A and B when A divided by B is equal to Q plus R, where R is the remainder, is equal to GCD of B and R until dr is equal to 0. My second line loops the calculations until B is equal to 0. Third line gives temporary original value to B. Third line tells it to replace B by the remainder of A divided by B, and to replace A with the previous value of B as the divisions proceed till the end of the loop. The last line prints the results for the assigned numbers. Again, after saving and exiting, I tell it to run the GS file with node and the file's name. Then we have Factorial using C++, again the nano file, and the first line includes the library for input-output, which we can view as a translator for me and the computer. For example, count prints the text from computer to human, while CIN reads the text from human to computer. The second line, the STD, stands for standard. It tells it to read your code in the standard namespace. Namespaces help put codes in logical categories and avoid name collisions. For example, in this case, it tells it which count or COUT I mean in my second to last line. The INTs in the third and sixth and seventh line stands for integers and tell it to store whole numbers. But what is the difference between int factorial and int main? Int factorial gives the general rule, the main formula to solve any factorial with, and int main gives it my specific problem to solve using the general rule in the int factorial. In my int factorial, my lines mean if n is 1 or smaller, stop and return 1, but if not, calculate n and return n times the factorial of n minus 1. In my int main, I assign it to take n as 5, and count tells it to return to me, print on the page, factorial of 5 is 120. And the return 0 tells it that the program is finished. Then after saving and exiting, I tell the terminal to compile C++ code into an executable named factorial, and then run the program and get my output. We must do this compilation step since C++ is a human-readable language, therefore can't be understood by the CPU, which reads machine language, also known as binary instructions. Next, I move on to solving a factorial on Lisp. I open a nano file. The defun in my first line defines a function in Lisp, and factorial serves as the name. The n makes the function take one argument n. Everything else inside the parenthesis here is the body of the function. From here, we have a similar logic as to the C++ example. If n is 1 or less, return 1, otherwise return n times the factorial of fn minus 1. And my last line format prints output similar to count and C++. T tells it to print to the console, and the continuation in the quotes is the string. Factorial of 5 is printed as is in text. For A is the placeholder for a value. The continuation in the quotes is the string. Factorial of 5 is printed as is in text, and the continuation A is the placeholder for a value, which will be replaced after what follows the string is placed. And the percentage symbol means to go to a new line. And factorial 5 is the value that goes into A. Lisp calculates the value and places it in A in the string, and the console shows factorial of 5 is 120. Then again, save, exit, and run it by Lisp file name. Then we have GCD in TCL. Open a nano file is quite similar to GCD on JavaScript. The first line defines the procedure in TCL. The second line gives the loop to 0 for the Euclidean algorithm. And the next 3 lines tell it to set an initial b value, switch b for the remainder of a divided by b, and replace a with b through the process. The return a tells it to give back the current value of a as a result once the GCD procedure finishes. And the final puts etc. line tells it to print the output as GCD of 48 and 18 is, and calculate the GCD of the values we assigned to A and B using the formula we gave it earlier. Then save and exit, use the command tclsh file name and receive our output. Lastly, we have checksum using Lua. A checksum is a numerical value calculated from a piece of data, which can be a string, file, or a message. And the purpose is to verify the integrity of the data. For example, if one component changes slightly, the checksum will change as well, signaling that the data may have been altered. Now, these are widely used in computer networks and file storages, as well as error detection systems. In my code, the first line defines a function to compute the checksum for a string, which is a sequence of characters treated as one piece of text. The second line, we make a variable called sum, and at first define it as 0. Later on, the variable will contain all the character values of the string. In line 3, we are starting a loop. I is the counter beginning at 1, which is our first character. The str means the number of characters in the string. For example, hello has 5 characters, so the str is equal to 5. So the loop will repeat 5 times, once for each letter of hello. Line 4, string byte, etc. gives ASCII code for the ith character. For example, string.byte of hello 1 is equal to 72 for the letter H. Then we take the previous content of the sum variable, add the ASCII numbers, and put the total back into sum. So we get 72 for H, 101 for E. Then we take the previous content of the sum variable, add the ASCII numbers, and put the total back into sum. So for hello, we get 72 for H, 101 for E, 2 108s for the L's, and 111 for the O, which in total gives us 500. And now our loop is done. However, computers often store checksums in 1 byte for efficiency, and a single byte can hold values from 0 to 255, and our total sum doesn't fit 1 byte, so in line 6 we take the total 500 and apply the percentage sign 256, which means divide by 256 and take the remainder, so we get 244. The function should also put the output as 244 for the checksum, and in the final line we just tell it what to print and the checksum of what string to calculate. Now, after saving and exiting and writing the command, we can see that the checksum of hello is indeed 244. We can also return to whichever one of the nano files we created if we want to make any changes, just like this. We see that the values also change. Thus, we can see that different programming languages can solve similar mathematical problems using different syntax, but with the same core logic regarding branching, looping, etc. And that's about all. Thank you very much.